Right, thanks everybody for coming, and please welcome Benno Rice.
So I know this may come as a shock to some of you, but I have opinions. So this is one of those talks where I started, I had a kind of idea, and then I came up with a title, and suddenly it all started to really come into place. Because, especially when I looked up what Wikipedia said that tragedy meant, which is a form of drama based on human suffering that invokes an accompanying catharsis or pleasure in audiences. And I figured there was enough suffering in this whole subject to go around, and, hopefully I can deliver some pleasure onto my audience. Another big influence on this talk is a piece that everyone should have read by now, and if they haven't, please go read it. It's by Aurynn. It is called Contempt Culture. The gist of that piece is that people use contempt as a social signifier. And the piece itself is largely based around language communities, so the Python community rags on the Perl community, and the Perl community rag on the PHP community, and so on and so forth. But a lot of the concepts in it are largely applicable outside of that. And the last concept that really fed into this talk was change. Change is a tricky thing because change threatens what we find familiar. And familiar is nice, familiar is comfortable, but that doesn't always mean that it is good. And it certainly doesn't mean that it is still good now if it's been around for a long time. So someone also told me that tragedies come in five acts, so let's start with Act 1. So in the beginning, there was Unix. Well, there was a lot more before that, but for the purposes of this, we're going to start with Unix. Unix was a happy accident. If it had not happened at the place that it did, in the time that it did, in the way that it did, it just would not have turned into the thing that it did. It was a reaction to a bunch of previous systems in that it was brutally simple. They looked at a whole lot of the other systems that were on offer at the time and went, you know what, this is just trying to do too much. We can do better than this. We'll just start with the small stuff and work from there. And it takes this brutally simple approach to bootstrapping itself. And especially in bootstrapping user space. This is the manual page for init. It says init is evoked in the last step as the boot procedure. Generally, its role is to create a process for each type. Moving on. When init comes up multi-user, it invokes a shell with input taken from the file, housekeeping functions, fork several times to create a process for each type. Sorry, that's 7th edition Unix from 1979. The thing is, though, it still sounds pretty much like what the old school init does. But one thing that I really bumped on when I was reading through this is the phrase housekeeping functions, like mounting file systems and starting daemons. There were two things to that. One, the main thing that really got me on that was that they lumped those two together, and I'll get back to that in a sec, though. But given the context of what daemons meant at that time, this is the PS output on PDP 1170 running 7th edition Unix. As you can see, there's not much going on there. Init has been forked several times to act as for terminals or typewriters. You've got cron there, and update's job is to write the file system super block out every once in a while so that it doesn't go away. And the things, it didn't change all that much over time. Like this is VAX 11730 running 4.3 BSD. And as you can see, things haven't changed all that much. We've actually got a proper Getty there. And for those who don't know, Getty is the thing that handles serial consoles, which are something you should ask your grandfather about. Or grandmother, sorry. And it's got a route D and an inet D and a couple of telnet Ds. And that's kind of where things started to get interesting. Because inet D was the kind of a service super daemon, if you like. Its job was to listen on all of the sockets that something could connect on and fork off a process to talk to it when it came along. And that worked really well up until the internet happened. Just before I move on, big thanks to the Living Computers Museum+Labs who gave me access to those machines to get the screenshots. They will also give you access too if you ask them nicely. For whatever you want to do on a PDP 1170. So, the internet happened. That inetd model was great when what you were doing was dealing with a small amount of stuff going on. Like the amount of traffic that goes over a telnet connection is not actually all that much, and there's not a lot of state going on that isn't ephemeral. If the connection drops, then you just reconnect and you get your state back some other way. Same with FTP, same with pretty much everything that inetd handled. The web looked like it would work that way, and then it became really, really, really popular. And so you end up with situations where forking off a process to handle every single connection doesn't really scale that well. Then you also get these rather annoying things like databases, where you have a ton of persistent state and you don't really want them to go away in between invocations. And so this leads us to what we know these days as a service. It's kind of a superset of a daemon. It quite often encompasses multiple daemons or a whole bunch of clones of a daemon or various things like that, a contiguous set of processes and behaviors. And init, old school init, can start these things, but they don't really get involved with managing them after that. They just kind of stand them up and then walk off, and if it falls over, they go. And even with System 5 features like init tab, which can restart things, because the only thing that gets restarted properly on old school Unix systems is Getty. Getty will get restarted as terminals come and go. With System 5, the init tab let you specify other processes to do that, but again, it's just if this process crashes, restart it. It's not particularly granular. And that's not the only thing that init and etc. RC had to do. So coming back to this quote, it conflates mounting file systems and starting daemons. These, I think, are two separate but kind of related things. One of them is system configuration. And by configuration, I don't mean editing files and etc. I mean, like, you know, when a pilot lands a plane, they put the plane into a landing configuration with the slats and the flaps in various settings. System configuration is making sure that your file system is mounted, that your interface is configured. These things are kind of set and largely forget. But it conflates these with service Bootstrap, which is start that daemon and then walk off and don't care anymore. And this gets commingled in a bunch of ways that we don't often see because we're really familiar with it. And it really gets in the way of things like automated service management. Because that's not there in this setup. And that's where things like upstart and systemd start to show up, because they deal with the services that need more active management. Before we move on to other things, let's look at some other operating systems. Windows NT had a very strong, well, has a very strong service model that came with it from the very start. A lot of it was based around a particular process called SVC host, which led to a whole bunch of things like security issues and stuff like that. But in general, its service model, including starting, stopping, restarting, auto-restarting, and all that, was there from the beginning. And a lot of this comes from its sort of heritage as coming from one of these way too complicated operating systems that Unix was railing against. Another operating system that has a very good service model, at least these days, is macOS. And its derivatives like iOS, watchOS, tvOS, and caros, and whatever else is coming down the pipe when they release stuff. So macOS's application model also gives you a bunch of interesting stuff in that it allows you to have a much richer interaction with your host. macOS and iOS applications generally take the form of an application delegate that receives a whole bunch of calls in from a surrounding environment that tells it that things are happening, like you started. You're going to quit now. The system's running low on memory, and if you don't do something about it, I'm going to kill you. Things like that. The other thing that came out of Apple was launchd, which is a good point to go to Act 2. So, what even is systemd when you actually get down to it? So, starting off, launchd. Launchd showed up in macOS Tiger. It rapidly took over most of the sort of service handling stuff in macOS, and it replaced almost every single what I would call event handling daemon in the entire system. So it took over init, It took over cron and at, it took over inetd, and it expanded from this inetd-like concept to go, hang on, I've got all of these sort of service-providing daemons that form part of the system that don't need to be running all the time, but they need to be brought up when we need them. And so it can listen on not only TCP ports and Unix sockets, but also MARC ports and things like that, so that it can start these service daemons as they're needed. And once you've got that, you don't need to start them at boot time, and that speeds the whole thing up. It also can restart things if they're needed. If they do need to be started, then it can watch the process. If the process exits, it restarts it. Great. So the idea of launchd was to move as many system services as possible into these daemons that could then be started as needed. Because when you think about it, the actual underlying system, when you're talking about a system like macOS or Windows, or even like Linux if you're running a desktop spin with GNOME or KDE or something on it, is a lot bigger than you think. So on macOS, the services get started with something asked for them, which means you improve boot times, you improve power consumption, you can improve security by making the access to these things granular. And Apple can do a lot of this because it's got this pervasive use of MARC ports and messaging systems underneath it that it can use to do this. One of the things that I pointed out, because this talk started out as a keynote for a BSD conference, one of the things that I like to point out here is a lot of the BSD people who like to gripe about systemd, if you actually say, oh, you could, why don't we do launchd? Like, oh yeah, I like launchd. And it's like, you realize that systemd is basically a rip-off of launchd, right? Because 5 years after launchd, this guy that no one's heard of called Leonard Poettering was looking at Upstart and a couple of other things and didn't quite like what he saw. Upstart, which was an older startup mechanism, usually used on Ubuntu, I think. It was event-driven, like launchd and systemd. It still used shell scripts. It could handle more event types than init, which is not hard. But Leonard seemed to feel that it didn't do enough with dependency ordering and had a bunch of other things missing. And so you can find this blog post. This is basically where he introduced the notion of systemd. It goes into detail about the rationale behind it, and so a couple of interesting quotes. For a fast and efficient boot up, two things are critical: to start less and to start more in parallel. It doesn't really go into, it's not overly concerned with boot speed, but that sort of gets in as a side thing. An init system that is responsible for maintaining services needs to listen to hardware and software changes. This is exactly the kind of thing that macOS and iOS do really, really well. When you are a modern operating system, you live in a much more dynamic environment, and yes, even if you are running on a server or a virtual machine, than you used to. And a lot of these things need to be dealt with, and a lot of these things come in as events that need to get handled. And so if you move from the notion of system bootstrap to I'm going to handle events, then systemd does that really well. And he literally cites launchd as an inspiration. In this, is this kind of logic new? It is not. It is basically launchd. And I get the impression sort of from this that Leonard likes a lot of what Apple does, even if he doesn't like their implementations of it, because his previous projects before this were an implementation of Apple's Bonjour system and an audio system that he directly compares to Apple's Core Audio. So we've kind of evolved here from a service manager to a system manager. And again, there's parallels with Apple here, because systemd, like, even though it started as an init system, sort of rapidly spiraled out and started taking on other things, which, you know, in one way is a fairly logical reaction to this. We're going to react to system level events. But I think what they rapidly came across is an idea that it took me a while to get onto too. A lot of people think of a system as having two parts, user space and kernel. You know, the kernel looks after the hardware and things like your TCP stack, and your user space runs daemons and whatnot. But a lot of things that used to be static in the kernel are now a lot more dynamic. I still remember building my own FreeBSD kernels and basically having to say, this card is in this slot with this IRQ and this kind of stuff, and now that's all dynamic. And it can change a lot more. Networking is a lot more dynamic. DHCP, IPv6 autoconfig, all these kind of things are more dynamic. Time is more dynamic. Some aspects of device handling, all of these things are a lot more dynamic now, and we need a way of strapping these things together so we can manage them that doesn't involve installing 15 different packages that all behave differently. And so what that ends up becoming is what I term the system layer, which is a bunch of stuff which might be running in user space or might be running in kernel space, but is providing systemic level stuff as opposed to the stuff that you're writing or using directly. So this could include things like Network Manager and UDEV and a whole bunch of things. And systemd as a project ends up complementing the Linux kernel by providing all of this user space system layer. It doesn't do it in a way, though, that is familiar to everybody who's used to the old way of doing it. But it does mean that people can stop reinventing this by strapping together 15 different disparate packages that all have different configuration file formats and different behaviors. That can be a possible source of angst, but it does sort of explain a bit better the reason why you would inhale that other functionality. So how does this work in reality? So systemd actually got fairly widely adopted, not universally. These are all of the dates at which systemd entered particular distributions, and between these distributions here, you're covering like the bulk of the installed base of Linux, I would suggest. I don't know that for sure, but someone will probably come up and tell me if I'm wrong. Debian is an interesting one on that one because they had a very long debate about whether to take it in, which was understandable given that they have multiple kernels that they run on. You can get Debian on the FreeBSD kernel if you so desire. And there's there are a bunch of arguments there, and the really nasty bit is that they ended up going with it, but a lot of the people involved in steering that discussion ended up resigning. So the next bit that I want to go through is some of the more common arguments against systemd that people tend to advance. It violates the Unix philosophy. This one I often find is predicated on the notion that systemd is one binary, because if you were to have a DHCP client, an NTP client, all in one binary, yes, I would agree with you that would be a bit silly, but it's not. It's a bunch of separate binaries that are all in the one project, and being a BSD person, I do kind of understand the notion that you want to bring a bunch of disparate code into one repository to manage it centrally. The next one is that it's bloated and monolithic. Again, it's not really a monolith. I can kind of understand why people get bent out of shape that it's inhaling a bunch of other project functionality, but I do understand why they're doing it to some extent, and so, I'm not particularly worried about that. It's buggy. It's software. The thing is, though, that this argument comes in a bunch of forms. I mean, yes, systemd has bugs, and yes, they're going to stand out because it is such a core component at that level. But there also seem to be a subvariant of this where, like, oh, well, if you're going to write an init, you have to be this bug-free in order to drive, which it really raises the bar to replacing that particular bit of code, and I don't think that's the right way to do it. And I mean, it also has a reasonably good failure mode where it just, instead of actually crashing and taking the system down, it'll go catatonic, so you can at least choose the point at which you reboot. But in general, I mean, I do sympathize with some of the bugs, although there was recently a rather fun instance where there was a bug in journald that I believe led to code execution. Some little-known hacker named Matthew Garrett pointed out that, in his opinion at least, the moral is don't use systemd. The moral is, maybe don't use C for these things. To which there was a response of, actually it means don't use systemd, and so on and so forth. To which Matthew replied with this, which needs a little bit of explanation, in that Howard Chu is the chief architect of the Open LDAP project. And that link was to a list of CVEs in Open LDAP. All software has bugs. Some bugs are going to be security issues. Systemd does have some fairly impressive bugs, like that journal debug, they were allocating memory on the stack. Don't do that. But that said, I think that there's an important distinction to be drawn between systemd, the implementation, and systemd as a set of ideas. On top of that, another one that people like to come up with is this one. I'm not going to defend Lennart's approach to community interaction. But what I will say is, you have to admire the willpower and determination of someone who, at work one day, goes, I'm going to write my own init system. Actually, no, it's going to be a full-on system layer for Linux. And takes it to his management and goes, hey, I'm going to do this. And they go, nah. And he goes, no, wait. And then he comes back with it, and it works. And then he gets it put into pretty much every major Linux distribution. There is something to be impressed by in that, even if you're not impressed by his attitude on the GitHub bug tracker or whatever else. Another one that is particularly interesting to me is it's not portable. Now, this interests me because, for those who don't know, I'm a long-time FreeBSD developer. Systemd is aggressively Linux-specific. It uses a whole bunch of Linux-specific process maintenance hooks that just aren't present on other systems. And so if it becomes the sort of established way to manage services, it runs the risk of isolating the other platforms that don't have those things. But it gains a bunch of really important functionality from those things. cgroups is a really interesting thing. You could argue that it should stick to more Unixy interfaces doing these things, but the reality is that Unix is dead. So Unix was all about maintaining portability across a pathologically diverse range of platforms. When the Unix notion came out, when POSIX first showed up, what it was there for was to make it so that if you wrote code on 4.3 BSD on your VAX, I don't know if POSIX was around at that point, but it was not too far off. It would also run on Sunos and AX and whatever digital Unix was called at that point, and so on and so forth. Like, there was just these enormously disparate range of Unix platforms that things could run on, and so everyone kind of needed to agree on how to do that. These days, I think you've basically got Linux and some rounding errors. I'm sorry to all of the Solaris devotees out there. And I'm saying this as someone who has spent a large amount of his time and knows a significant amount of his career to FreeBSD. FreeBSD is no longer in a position where it can go, hang on, we should do this with an interface, because the entire Linux community would just go, well, I don't care. Whereas Linux can go, okay, here's cgroups, take it or don't. It's an interesting position to be in. So we've gone from this pathological diversity to a pathological monoculture, where one platform can effectively dictate what the terms are. Systemd gains a great deal from using things that are not Unix. And one of the things that I pointed out when I first gave this talk is that this doesn't have to be a net negative, because it means that FreeBSD and the other projects could also feel similarly liberated and try and create whatever they wanted to without having to go, hang on, what does Unix think of this? So, and cgroups is the thing I keep coming back to with this. Cgroups is a really powerful mechanism for creating manageable groups of processes. I mean, FreeBSD came up with jails ages ago, but when I look at jails, they're a lot less flexible and a lot less granular than what you can do with things like cgroups. Another thing that I think that systemd gets really right is the notion of user-level units. If you want to do a user space daemon, as in a daemon that starts up and runs as you, without you having to become root to install it, on FreeBSD, it's really hard. You basically have to write a shell script that's then going to su as you and do all that kind of stuff. With systemd, I can just drop something in a directory in my home directory, and if the thing's set up right, it just starts. I mean, the other way you can do that is to play around with cron, but playing around with cron can be fun. So it all comes back to change. Systemd represents a large amount of disruptive change, which brings us to the actual tragedy of the piece. So yeah, people have a complicated relationship with change. I like to say that nerds especially have a really complicated relationship with change. We love it to pieces. Change is awesome when we're the ones doing it. As soon as change is something that's coming from outside of us, it becomes untrustworthy. And it threatens what we think of as the familiar. People like me grew up with a notion of, init runs RC and RC runs a bunch of shell scripts and then the system works. And that familiar might be good to us because we understand it. It's our comfort zone, it's what we're used to. But I think at this point, like a system Bootstrap that relies on shell scripts and relies on understanding how those shell scripts work and interact and are ordered is kind of like the old tired old blankie that we maybe should have handed off about 20 years ago. And systemd represents change. And it represents a really disruptive level of change. And it represents change that was pushed on us by people like Leonard Pottering, whose ability to have sympathy with the people who he's asking to change doesn't appear to be the greatest. But what this leads to is a knee-jerk reaction. Because the lack of sympathy isn't just on Leonard's side. The reaction to systemd got a little bit over the top in some places, I think. Abuse is not cool. No one needed to send death threats to Leonard Pottering over a piece of software. And it's not just abuse, contempt is not cool. And this was one of the things that I really wanted to ram home when I gave this talk at BSDCan. FreeBSD should not be proud of the fact that we don't have a systemd. We should see that as we're lacking something. Like, if we're mocking the fact that Linux has systemd and all those poor Linux users with their terrible software, then it means that we're treating it as a joke and not as a source of ideas. And that doesn't just apply to FreeBSD, it applies to pretty much anyone who sits there going, oh no, systemd's terrible. It's like, no, look at it a bit. And one of the biggest problems that I had with the FreeBSD community on this one was things like this. Because to me, this says on behalf of my community, come join FreeBSD, we'll never change. We refuse to move forward into the future. Anyway. And so really what I want people to do when they look at something like systemd, whether they like it or whether they don't, and especially if they don't, is why. Why did systemd show up? Why is systemd important? Thinking about that means that you suddenly go, hang on, so is systemd solving a problem? What problem is it solving? Could I solve it better? Because one of the solutions, if you don't like systemd, is to go and make your own. At the very least, you're going to find out how much fun that is. And then another angle on this is that it's not just about us greybeards. The next generation of people who are coming into IT, coming into software engineering, coming into systems administration, they don't necessarily think about the systems they're running in the way that we do, or that I do. they see a lot more APIs in the sense of like web APIs. Like 20 years ago, me going, oh yeah, I can spin up a Unix machine by punching a HTTP API on a bookstore. That would blow me away back then. And also things like containers. Thinking in containers ends up making, you end up thinking quite a lot differently to thinking in not containers. So on and so forth. And so this brings us to the last bit. What does systemd have that we could learn from? Or what does it offer us? So this is a section in the original talk where I basically told a bunch of BSD people what they could do if they had something like that. But I think there's a bunch of interesting, like if you go up to the higher level of what systemd has, there's a bunch of really interesting stuff to think about. Messaging transports. Systemd makes heavy use of dbus. I'm not a big fan of dbus, but I am a big fan of messages. Apple uses Mark to do the same kind of thing. One of the things that I told the BSD people was basically we should write our own message transport. My version, if I were to write one, would be kernel resident rather than user space. And it would allow a lot more sort of security and authentication and access control elements on the actual bus endpoints. But you people can write your own. Because once you've got a message transport, it's a lot easier to write an RPC framework. And the question is, why do you need this? And the answer is because if you need a leveling mechanism to make the kernel and user space operate at the same kind of level as far as the code above them is concerned. You don't want to know whether a particular service that you're talking to is handled by the kernel or by user space. You just want it to happen. You want to be able to send out an API request that says, okay, network interface, take this IP address, and just have it happen. You don't want to have to worry about, am I talking to the kernel or not? The other thing that systemd gives that a lot of previous systems didn't give you was a proper service lifecycle. As I said, Windows had this from inception. macOS sort of organically grew it, and then once they came up with LaunchD, sort of massively pushed towards it. And does this without you having to install one of several different systems that all work differently, like OpenRC or Runit or SupervisorD or any of these ones. Automation via API sounds blithe, but once you can automate the setup and configuration of a system through an API that isn't sort of having to shell out into system calls or anything like that, you've basically written most of what an appliance vendor would need in order to make a really good appliance. So you could think that things like OpenWRT could use it, but then in my case, I used to work for a company that made large storage appliances. It would have made our job a ton easier to have that kind of thing. And I think the last really important thing that things like systemd enable through the use of things like cgroups and stuff like that is containers. I think containers are really interesting, not because I think that they are the savior of security or anything like that, but just because they provide you with a way to encapsulate things in a way that's quite cool. And so systemd providing the system layer gives you a more consistent platform for doing that kind of stuff. And the barrier to entry for building something on top of this like an appliance is massively reduced. But again, systemd doesn't have to be the only implementation of this. You should go and explore. But moving on, I think that the way systemd names devices is actually really good. And I say this as someone who used to spruik the FreeBSD notion that every Ethernet driver should have its own name. And while I also did not like the Solaris naming scheme of like C0, T0 for disks, I think that having consistent names that are generated on physical attributes of the device is a lot better than having them named after what random order they happen to show up in. I also think that systemd's model of logging is really good. Binary logs are not a bad thing, as long as you have the tools to pull them apart. But having append-only logging in a system like that, especially append-only logging that can be shipped off somewhere else easily, is, I think, very handy. But the other thing is that with containers and a whole bunch of other things, you get a new model of an application. An application no longer has to be a single binary or a single binary that starts off other things. It can be an encapsulated series of things that are managed as a unit. I think that's really powerful. I think it would be really interesting also to look further on at how you would do a macOS-style application on a platform like Linux, being able to provide a lot more feedback from the host system about what's going on so that it can react to it. So at the beginning of this talk, I showed the Wikipedia definition of tragedy, and it mentioned that it was causing catharsis in people. So definition of catharsis, meaning a purification or cleansing, the purification and purgation of emotions, particularly pity and fear, through art or any extreme change in emotion. What I hope that this talk has provided is a removal of fear, and particularly a removal of pity of systemd and the people who actually use it. The world is changing around us, and we can either get with the change or we can try and resist it. And this applies in so many ways. It's not just software. There are a whole bunch of changes that go on that we really need to logically evaluate and work out whether we're on the right side of. We can try changes. You don't have to commit to them until you know that they work. I mean, a lot of distributions had other systems that they replaced systemd with and worked with it. So yeah, what I would challenge everyone here is look at systemd and try and find at least one thing that you like, and then go see if you can implement it. Thank you. Yeah, I'll do some questions.
Okay, we've got some time for some questions.
Please try to make sure that they are actually questions. I've given this talk before, and as you can imagine, I occasionally get diatribes in the form of questions. Not in the form of questions.
Would it have been feasible for LaunchD to have been ported across to Linux? And would there have been any advantage or disadvantage in doing so, given that Apple had already done some of the work, and presumably that was open sourced as well?
So if systemd is aggressively Linux specific, LaunchD is aggressively Apple specific. It deals with a lot of mark ports, and it also is, I mean, Apple have done some work to try and make it portable. I know that they offered to try and make all the libdispatch bits and everything that we would need in order to do that on FreeBSD, but it sort of petered out because I think they're focusing on making sure that it works well for them, which is fair enough in the same way that systemd tends to try and work well for Linux.
Benno, you said that containers enable a whole new way of thinking about applications that can now be managed as a unit. We just spent the last couple of decades getting really good at dynamic library management. Mm-hmm. Now this is starting to look more like DLL hell. What are your thoughts on this?
Well, I think so DLL hell to me is more having 5 different versions of a library and always having your applications pick the wrong one. I think containers explicitly avoid that particular version of it. That said, I think there's a different version of it where you might have different versions of a container running and that kind of stuff. But I think that containers explicitly avoid that in the same way that Go tends to avoid that kind of problem by statically linking everything.
Would you be willing to come to Linux Plumbers Conference this year in Lisbon, Portugal, and run a systemd micro conference? I've already talked to Kay and Leonard. They said they might show up too, but I want to get...
I'll take that I'll take that on notice.
G'day. I really enjoyed that, and I really appreciate your talk that many of us really love change, where we're the ones saying, hey, you should change, and we don't like it when things change on us. Do you feel there's been any kind of chilling effect with the reaction to systemd being so hostile that may be causing other people who have good ideas about how to do stuff saying, well, I'm not going to stick my head over the parapet, I'm just going to get shot?
It's possible. I mean, whenever you're touching code like that, it's going to cause angst. I think the overreaction to systemd, like, you know, the stuff that Leonard copped, I think is going to have some effect on that kind of stuff. I mean, the other thing, though, is that literally writing that kind of stuff is a lot harder than you think. That doesn't mean you shouldn't try. But really, I think one of the challenging prospects of bringing something like that into the world is managing the people that you're trying to accept, trying to get to accept the change. And that requires a certain level of social ability that is beyond, I mean, hell, I don't think I'd do a very good job of it. And it's one of the reasons why pushing for that kind of change in FreeBSD was something that I kind of wasn't sure how to achieve. And so I resorted to just yelling at them in a keynote.
As a FreeBSD curious Linux user, where's FreeBSD at with next generation kind of net?
There's a project called OpenRC that handles some of the service management bits. But in terms of a holistic notion of a system layer, they're a long way from that. And that, I think, is one of the things that I find frustrating in this discussion, in any discussion around this, is there are far too many people who immediately default to this notion that systemd is only about starting and managing services. When, in my opinion, if you're really going to do that kind of thing, you need to look at the whole thing. That doesn't necessarily mean you have to do it all in one project, but you have to do it with a level of holistic intent, if that makes sense, because you want it to be somewhat uniform and manageable.
Thank you for expressing better than I could and much better than I can be bothered a lot of thoughts that I've had as well. As you said, systemd kind of swallowed up a whole bunch of previously separate system services. Do you have any opinions on whether they all make sense or some of them make sense and others less so?
Okay, so here's an interesting thought experiment. If systemd had not brought those things in, but had instead worked on defining an API by which those services could be managed, then they possibly would not need to be in the same project because you wouldn't be needing to keep the same level of control. You could have a bunch of implementations of, say, the network manager API or the time management API or that kind of thing that would be interchangeable to some extent. I can kind of see why they didn't go that route, in that it's not immediately obvious until after you've done the first thing. Like once you've pulled everything in and gone, oh crap, we need to be able to manage that too, and we need to be able to manage that, and we need to be able to manage that, and so you've brought everything in together. At that point you kind of go, oh, hang on, if we'd actually just defined the interfaces a bit better, then maybe we could have avoided that. That's the kind of thing that you see in sort of as an afterthought. But yeah, I think I can see logic as to why they would have done why everything is there that they've brought in. But whether they need to be there in the long term is an interesting question. And if you were to write your own implementation of that kind of thing, then there are ways that you could avoid having to pull all those things into one thing.
Hi. From what you know, or at least could imagine, what would you think advantage of using systemd on embedded devices as opposed to desktop and servers? To start with, I can think of being able to restart your services on embedded devices that no one's going to be monitoring. But what are your thoughts on this?
If your embedded device has any level of dynamism in its environment, like if things are getting plugged into it, then it gives you a hook to do that. If you have the APIs for managing things like that, it means that the code that you have to write in order to implement your embedded device is hopefully less. It's that kind of thing.
You mentioned that you'd given a similar talk to some FreeBSD developers or FreeBSD users.
Yep.
Yeah, did you get a lot of pushback on that? And if so, was there a major category of pushback that they specifically got?
The only real pushback that I got was, okay, we're on board with the notion that we need something like it, but as long as it's not systemd. Which, you know, all right. Well, no, there was an attempt to do that, and including porting over a markports compatibility layer, so don't joke.
Thanks for that. Given the interactions between the community and the systemd team in both directions have not always been the most positive, to put it mildly, you know, we're in a situation where the systemd team doesn't really listen to or take on board community concerns, but at the same time, the community is not really listening to the systemd team and their vision. What needs to change both in the community and, say, this room and broadly, and also in the systemd team in order to facilitate a better working relationship going forwards?
That's a really tricky one.
That's why I'm asking it.
Yeah. So one thing you could do is watch Adam Harvey's talk about version upgrades, language version upgrades, because in it he discusses this notion that you have to give people reasons to change, as well as just beating them around the head to say, don't do that. Having a combination of those things would be good. I think the problem that, I mean, I'm speaking from a position of profound ignorance here, but were I in the systemd author's position, having a whole bunch of community people coming to me and saying, I want X, Y, and Z, and they want A, B, and C, and these people want something else, and at least 5 of these things conflict with each other, that's a really hard set of constraints to try and work within. And so I can see that there would be a temptation to just tell them all to get nicked. That doesn't mean that that's the right thing to do. I do agree with you that the relationship between the authors and the community seems fraught. I think I don't really know the right way for them to fix it, but it probably involves a lot more sympathy on both sides.
To somewhat tie into that, are there any particular areas you think systemd should go a lot further in?
I would very much like to see the messaging and RPC stuff become a lot more pervasive and a lot more thought about, if that makes sense. I mean, I'm sure they are thinking about how that works. There's been multiple attempts to get a dbus style transport into the kernel. I think that having that, even if it's not necessarily dbus, would be a really interesting thing to play with, because it puts a lot of code on the same level. And it also allows a lot more control and interesting security features that you could do by having it in the kernel.
All right, we're out of time, so thank you, Benno.
Oh, thank you very much. Nice.